Attempting to be thematic about these. So the next ones I'm going to do is looking at these sequences here. So for this sequence, we're trying to figure out which rule works. And say you had absolutely no idea how to do this. You could just plug in 1 or 2 or 3 or 4 and see which one gives you the answer. So great. The way this is looking at this is saying this is plus 10, plus 10, plus 10, plus 10. So I'm going up 10 each time, but my original number here is -5 because I would have to go minus 10 to get back there. So this is my answer, but let's just assume that we knew nothing. If I plug in 1, I don't get 5 here. If I plug in 1 here, I do get 5. If I plug in 1 here, I do not get 5. So then, and if I plug in 1 here, I also get 5. So then we plug in 2. If I plug in 2, I don't get 15. So this would be the only one that works for them. But you need to be careful that you don't just look at 1. And if you want to only try 1, you can probably try one of the later ones, and those will work out a little bit better. So let's look down here at 28. For 28, the sum of the infinite geometric series is a formula. It is the first term divided by 1 minus r. R is the ratio. R is our multiplier. So again, this is the first term, this is the multiplier. So our first term is 2, and I have 1 minus, what I'm doing each time is I'm dividing by 2, so my multiplier is 1/2. So I have 2 over 1/2, and a division problem is 2 times the reciprocal, which gives me 4. So that's my answer, but let's just look at this for a moment. Here I have 2 plus 1, which is already more than that, and I have 2 plus 1, which is already more than that, and I have 2 plus 1 plus 1/2, which is already more than that. So by just looking at elimination, I could also figure this out if I was stuck on this particular problem.